Hello, Coach Travis here with another calculus video. Alright, so this time this is a problem about the derivative of trig functions, but also we're also going to get to use the product rule here as well. So the thing to remember is basically we're building a toolbox full of derivative shortcuts. So the product rule is a tool in the toolbox, and you know that you're going to have to use that tool whenever you have two functions being multiplied together. So like in this problem, there's kind of an invisible multiplication sign right there. So this is definitely going to be a job for the product rule. Oops, I think I'm off the screen there. Let me try that again. This is definitely going to be a job for the product rule. And along the way, we're going to have to find the derivative of trig functions. So, all right. So remember the way you do the product rule. The way I think about the product rule is you've got like a first function, and so in this case, that looks like it's negative x cubed minus x squared plus x, and then you've got a second function. And in this case, that's cosine of x. So those are the two functions that I'm multiplying together. And the product rule says I need to know the derivative of both of these functions. So I need to be able to find derivatives of both of these functions. Alright, so let's see here. So the derivative of the first function should be no big deal using the power rule. So we're going to get a negative 3 times x squared, and then a minus 2 times x, and then a plus 1, because the derivative of x is just 1. And then the derivative of cosine. So the derivative of cosine, you want to go back to your table of, if you haven't, this table you probably should have memorized, by the time you finish calculus. You want to have this table memorized. But the derivative of cosine is negative sine. Okay, so the derivative, this derivative over here that we want to put in blue, the derivative right here is going to be negative sine of x. And alright, and so now the way I think about the product rule is the product rule says that I multiply along the diagonals, and then I add the results together. So we get, so this is the way I like to organize my work. I think about these are all my ingredients. That is the first function, the second function, the derivative of the first function, and the derivative of the second function. Those are the 4 ingredients for the product rule. And then the product rule is the recipe that tells me how to combine the ingredients. So it says you multiply the first function and the derivative of the second, and then you add the second function times the derivative of the first function. So alright, so let's see what colors. So we got the first function. The first function is negative x cubed minus x squared plus x. Oh, and I'll make a point here. These parentheses are really important, because let's see what happens if I don't put these parentheses. If I don't put these parentheses, then I'm going to put a multiplication sign here, and then I'm going to multiply by a negative sine of x. So I'm doing the first function times the derivative of the second function. And if I don't keep these parentheses, then the only thing that's actually getting multiplied here is the x and the negative sine of x. But that's not right, because this blue negative sine of x needs to get multiplied by the entire first function. So these having parentheses are really important here. So I'm going to put parentheses around both of them just to be safe, but they're really important in this one because this is the one with the additions and subtractions. All right, and then not so fast. Now I have to do the other part. So now I do the derivative of the first function, which is negative 3x squared minus 2x plus 1, and then parentheses, because those are really important, and then that gets multiplied by the first function, which is the cosine of x. And that's it. That I claim, I'll circle that, but that should, oh yeah, wait, I lost track of the question. So let's bring the question back. There it is, that this big expression here, that is the derivative of this function right here.